Hello, it is Mike Levin on Saturday, September 25th, 2021. I am in the car on my way to pick up my kid, and I made my attempt at live streaming from the car. I figured 5G connection, the highway, a power cord on the phone, why not live stream to YouTube while I drive? Not so much. I've had 3 interruptions where I had to hit reconnect, so that's a 3-strike system. So now I'm just recording it directly. So I'll basically start over. It's a Linux, Python, Vim, and Git video. It's about muscle memory. It's about the 10 years or 10,000 hours per Malcolm Gladwell's fairly accurate assessment in his Outlier book that it takes to practice a tool or a discipline or a trade or a skill to get spontaneously expert at it. So the sooner you start, the better. As long as what you're starting is love-worthy, because you don't want to go too far down that trail and realize that you hate what you do. So one of the solutions to that is to keep it general so that the skill set that you learn can be adapted to this thing and that. So if what you do is you go to school for, 10 or 15 years to become a surgeon and you realize you hate performing surgery, well, that's too bad. However, if you put your 10 years in on tech tools, particularly ones for pushing the bits around in general that can be used for any purpose, like Python and data science stuff, you can work for any company, you can be in any field, everyone needs it, no matter what company, no matter what their goals and missions and objectives are, making better use of their data is what ails them. So it's a solid approach. If you like coding, data, abstract concepts, not particularly getting your hands dirty, but still delving into carpentry skills, the making of things, then software programming may be for you. So there's a lot of ways I can go with this, but I do believe I'm going to touch a little on Linux, Python, Vim, and Git, talk a little bit about my last video about where to run your code, and maybe continue on that a little bit, sing the praises of using a network application server, which is a home server. There's a lot of ways to get a home server and a lot of reasons to use a home server, not the least of which is so you don't suddenly start having to pay to keep your server in the cloud, right? That's a vendor trap. First dose is free. There's no downside to just starting out on the Google Cloud platform, the Amazon Elastic Computing Cloud, Microsoft Azure, whatever, Heroku, which sits on top of other services and provides higher level abstractions so that you don't have to deal with, virtual servers essentially and have to know that Linux is sitting down there somewhere. But the got you of all of these is that as soon as you get ambitious, as soon as you try and do something off the beaten track, the cash register starts ringing up and you start getting billed. You don't want to pay? Well, eventually your server disappears and all your work with it. You'll still have your GitHub code, but then you still have the issue of where to install it and get it running. But if you start out with a Linux container on, say, a home server, on, say, a network application server, running a Linux container runner, a web-based version of LXD, like I am with Container Station on the QNAP server, you have this wonderfully nomadic server that you can just back up directly to GitHub as if it were just software, and then pull down and have running with the native hardware advantage on any architecturally compatible hardware you happen to be sitting on. That generally means if, it's an x86 container, you need some x86 hardware, which is not a challenge. You might need to make the choice between between 64-bit ARM and x86 these days, but not a big issue. You can always just reinstall all your stuff with your server build script onto a different container. You can even do that automatically, have one for 64-bit ARM, have one for x86, but that's not what I want to talk about. The problem of where to have 24/7 non-cloud code running is now a solved problem. Yay, yay, yay! This is new, this is a game changer, and that is kind of our starting point now. I'll produce some more videos showing how to get scheduled services running without any third-party services except for Python. You just drop a Python script into a Linux daemon, a Linux service, and bam, you've got scheduling under Python context with the power of Python to manage your scheduling. You can use the built-in sched module or package. It's in the standard library. You can just use it directly, or you can pip install schedule and have a slightly better API for humans, the same way people pip install requests to have a HTTP package for humans. So even though I try and steer clear of the dependencies, if they're extremely popular dependencies like the requests engine, there's going to be many years of people copying their API. So like I'm switching from Kenneth Wright's requests to the HTTPX package because it supports concurrency better. I don't have to learn anything. It just uses the same API as requests. So I pip install HTTPX instead, and now I have more capabilities. And with very little new to learn, my muscle memory of knowing to, import HTTPX as requests, I can even rename it so all my code keeps running. One line of code on the import as nickname, and your code keeps running and you've dramatically modernized it. That's the kind of timelessness you're going for. And combine that with the muscle memory of your text editor so that you know where and how to edit these files. You start to get into the zone and into the flow on making changes, on improving, on refining over perhaps a lifetime. So the giant reset button is hit on technology people who take up the carpentry tech skills all the time because the text editor changes, the details of how you collaborate and distribute code change. All these things change over time with a little bit of drift. If you're on proprietary vendor stuff, it's not so little of a drift and it's not over so much time. It's dramatic changes all the time, here and there, poof, poof. It's like being punched in the stomach, and you have to not only retrain and relearn and gain back your hard-won muscle memory over an additional 5 or 10 years. Maybe it'll only be 5 years. You don't have to relearn everything. It's not like it's changing from a mouse to a trackpad on you, or is it? But you also have to pay for new licenses, pay for the next upgrade, and pay for a different service, So Fire in Motion, this is Joel Spolsky of Stack Exchange, Stack Overflow fame, Foggy Creek Software, New Yorker, Israeli, paratrooper, really cool guy. You don't hear from him much, but he was influential in the early days when these ideas were being formulated, and he called it Fire in Motion. The vendors are deliberately doing this to you to maximize their profits and to keep them at the top of the food chain, right? And the more you switch to free and open source software, the less of a victim of Fire in Motion, duck and cover, 2 steps forward, 3 steps back, you will be. The more of a master of your own destiny and fate you will be. So you switch to free and open source software, but of course there is such a huge world of things to choose from. And it's all shaped in a pyramid-like stack. But let's turn that pyramid upside down. It's an upside-down pyramid with hardware at the bottom, with rigorous, comprehensive abstraction layers at the tip of the pyramid on the hardware level. That's why Intel x86 is not so dramatically different from AMD x86. That's why ARM64 is now kind of coming together. It used to be a problem. The tip of the pyramid at the point for ARM was all over the place, and it wasn't such a point. It was more like a fuzzy cloud. But now that Apple did the M1 processor on ARM64, and Microsoft's been at it for a while with their Surface Pros, it's being unified. So you can kind of think like you're either targeting x86 hardware, or you're targeting 64-bit ARM hardware. And that's the tip of the pyramid, and the APIs there you don't even need to think about, because the software is dealing for it. The platform, the development tools you're using is dealing with it, because Python has been written for all the different platforms as a for example. And before you even get to the language portion of it, the operating system, Linux or Unix, has been written for all these different hardware platforms. And so the most things in common, the least risk of specialized knowledge is at the hardware level. This will never change. To be a true, powerful information technologist, you need to know yourself a little hardware. You need to be able to step in when hardware starts booting up and take control of that process, whatever it is, and make it do what you want as the next steps. You should probably know how to harden what things are running in software, to strip out everything you don't need, to create as little surface area for hacking, to close as much accessibility to it by first defense is not running services in the first place. Second defense is changing the ports over which those services run. Third defense is having some sort of firewall so that you can only poke holes to those obscured ports. Next defense is, writing good software that it reaches once a request gets through those tiny little holes you poke. So this is stuff you probably should know. This is not where infotech starts, but it's where infotech gets serious, right? Security context, a lot of issues about configuring machines in the first place, what machine images to start from, because it's always either a .iso image that you're installing an operating system from, or more and more often a Linux container image. For either the operating system or the applications, you start layering on top of it. So it sounds like DevOps. The word that has been thrown on it recently, combining network administration and system administration, is DevOps, because developers need to know a lot about operations. Okay, so you need to be a junior DevOps person if you want to be one of these, powerful tech people. And that starts with Linux/Unix skills. And even Microsoft knows that. They're now including the Linux kernel with Microsoft. And it won't be long now before Windows itself is just a proprietary graphical API sitting on top of the Linux kernel, just like Macs are the proprietary Cocoa windowing layer sitting on top of Unix. It's all the same. It doesn't make sense to have proprietary down at that hardware booting level. And when I say, at that low hardware booting level, it's just that Frankenstein moment of pulling the switch from turned off hardware becoming hardware that's capable of doing something. It's got some instructions that people know. It's not even the whole Linux command set or the whole Unix command set yet. You can actually have a Linux or a Unix kernel that boots into something that doesn't have the CD and ls commands there. It doesn't have a text editor like VI or Vim. It's just a naked, bare bones Linux or Unix system with just enough boot kernel to hand it over to proprietary stuff. That's what an iPhone is. That's what a Mac is to some degree, but it does have, of course, the Unix commands on there. So when I say what you should be learning is Linux, Python, Vim, and Git, it's just enough Linux to take control of a machine from that moment of power on and have it run as something, running your scheduled tasks, running as a web server, whatever. So Python then is what you hand control over as soon as possible after the boot kernel provides the Frankenstein moment. The operating system provides the usually GNU Linux compatible command set so that you know how to do stuff. Some operating specific functionality provides scheduling and system services that you can have a piece of code running 24/7 in the background, because after all, how can you have something running server-like if you don't know how to get something running and how to keep it running, right? So these things in the operating system that start running your code have additional responsibilities. It used to be that it had the responsibility of scheduling. There was cron at this level, and there has never been more suffering than trying to learn the cron API and understand cron tables. Pshaw, who needs it? When a higher level thing like Python can bring scheduling to the picture, all you're asking for from the operating system is to get this thing running and to keep it running. And that's where I talk about systemd a lot. So one of my next videos is how to get a systemd service running under those versions of Linux that have chosen to have systemd as their kind of monolithic oversight service in Linux. They're not all that way, but all the popular ones are. And this is why the Linux image I choose for LXD is Ubuntu, because you can be pretty sure the people who invented it, well, it's really Debian who invented a lot of this stuff. It's Debian who Ubuntu derives from, who Microsoft uses, right? So Microsoft uses Ubuntu, Ubuntu uses Debian, Debian uses the very generic, Linus Torvalds, GNU Linux boot kernel. I say it's Linus Torvalds. Linus Torvalds things is the boot kernel, and Richard Matthew Stallman's thing is the GNU Linux command set. So it's really, Linus and RMS. They call him RMS for Richard Stallman. Linus and RMS are like the copycat pair to, let's say, Dennis Ritchie and Ken Thompson, who invented Unix and the C programming language, right? So the real innovations were done back in the late 60s, early 70s in the halls of Bell Labs by Ken Thompson and Dennis Ritchie. Ken Thompson is still with us. He wrote a good portion of the Go language. So he's still doing really interesting industry-shaping things. Dennis has passed, though, often compared to Steve Jobs as the walrus who changed tech and the carpenter who changed tech. I refer to them that way. They're often compared to each other, but if you want a walrus-carpenter situation, Steve Jobs, who probably never wrote a line of code but is still a heavy-duty technologist, was the walrus. And as you can see, the walrus is most powerful. However, Dennis Ritchie, who invented the C programming language, but, not from scratch. He derived from BCPL that came before it, that did all the virtual machine tricks that's necessary for porting between hardware. I forget who did that, but Dennis Ritchie took that and turned it into the C programming language, which was more capable and appropriate for writing the Unix operating system, which could be compiled for different hardware. Hence the information age was born, because you compile the operating system for different hardware, and software written for those operating system goes with it. A recompile ports your software to different hardware. And again, the inverted pyramid, hardware at the bottom, operating system, next little level up, and you go up the next level after that. Let's call it the developer platform, things like the Python programming language. Python is written for the operating system is written for the hardware. Okay. So by taking up something like Python, which is a fairly high-level abstraction in the inverted pyramid of dependencies, there is more stuff, right? There's less stuff because it's a tip of the pyramid in hardware. Truly, there's a lot of stuff, but it's abstracted down to a very small number of things you need to think about. You go up a bit, there's operating systems. Well, now there's, Unix, there's Linux, there's, until it's done away with, there's still Windows. There's other stuff out there. I don't know how much of it you take up these days, but technically there's Bell 9, which was a attempt at a Unix replacement. And there's a lot of operating systems out there, and variations. There's embedded versions, there's, desktop versions, there's server versions. So a lot of different, propagation of choices as you go up the stack. Python even more so. Similar issues as with operating systems. Embedded versions, the standard version released by the Python Foundation that came originally from Guido van Rossum, but now it's a group of people doing it. But there's PyPy, not the Python packaging index, but there's actually a compilable version of Python for optimization that does away with some of the dynamic features. You need to learn a slightly different API for some different objects in there, but you get, compiled C level performance. It's fast, PY. And so your choices of Python starts to expand a lot. At that level above the operating system. And you go even a level above that, you get to frameworks. And frameworks are a position of weakness. When you have to reach for a framework as your first thing you do, what you're saying to yourself is that you chose something wrong on your building of your inverted pyramid. You're sitting on the wrong stack because you shouldn't need a framework. Or more accurately, your programming language choice should be your framework. Ruby on Rails made this popular back in, the mid-2000s. I guess it's around 2006, 2007, with DHH, David something, a race car driver. But he wanted to create a framework for the Basecamp backpack software he was working on. And he created something that later got extracted out. He chose the Ruby programming language because he liked the pure object-oriented style. It was a kind of spiritual successor to Smalltalk, which was very well designed to be pure object-oriented, a lot of message-passing stuff. But Ruby followed in that tradition, and it's something that once you really understand it and grok it, and if you have a mind that is predisposed to object-oriented design, mine is not, I will tell you, it's easy to fall in love with Ruby, but Ruby didn't have enough. Ruby didn't allow him to do the things he wanted to do, so he created Rails, Ruby on Rails. Rails is the framework, Ruby is the programming language. And before that, it was things like Java, Hibernate, and Cocoon, and frameworks were profoundly difficult. I was around using those, particularly Java, Hibernate, and Cocoon, And it was horrible, 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 horrible. First, I hated the language, Java. And this is not JavaScript we're talking about. This was before JavaScript had become a stable, viable platform, before Node.js, before the Google V8 JavaScript engine. This was way back in the day. And if you wanted to do all these fancy web development and SEO tricks that I did, you needed to use a framework like Hibernate in order to spin out a bunch of static web pages, kind of the way that Jekyll does in GitHub today. And, you know, I learned it enough to do it and enough to learn that I hated it. So when Ruby on Rails came along, I'm like, yeah, I'm switching to Ruby. I'm all about Rails. But then I hated it because it forced, the Rails were not my Rails. They were other people's Rails. I did not like being forced to think and work in object-oriented notation. This dot, that, and very simple things in a procedural world became quite difficult for me in an object-oriented world. So I backed off of Ruby on Rails, but I became familiar with the concept of the framework. Rails is the framework, Ruby is the programming language. And it just extends the capabilities of the programming language and adds a lot of conventions. So Ruby in particular added conventions over config files. Before Ruby made it so popular, before Rails made it so popular to say, you just put a very small thing in place and everything else is figured out for you. It's interrogated, you know, your database tables are looked at, and sort of a scaffolding is created. The scaffolding could be in memory, and you could stick very close to the prescribed Rails, to the, you know, recommended, opinionated way of doing things, or you could spit that scaffolding out onto the hard drive and start overriding and overwriting those scaffolding files on your hard drive to customize it more and more, and to get rid of the framework opinions and to start inserting more of your own opinions into the picture. But your starting point was very much the framework's opinions, the Rails opinions of how things should be done. And this kind of stuff was often used to create CRUD applications. Often there's a SQL database with rows and columns in the background, and the capabilities are given are CRUD. You can create a record, you can read a record, you know, show it on screen, select it, a non-intrusive way of looking at a single record out of a database. CR, create, record, update. You can update that record, make changes to what you're looking at, and push it back up into the database, or delete that record. So things like Ruby on Rails were typically CRUD, CRUD systems, CRUD frameworks, cruddy frameworks. And another concept that gets introduced at this point is the MVC, the model view controller. The model is your database structures, which gets interrogated and figured out from, you know, the tools looking at your database table structures, especially if you have proper primary keys and relationships between tables. Almost your whole application is implied, and a good framework can just say, oh, here's your CRUD application. It's like you get simple things like, shopping carts are a perfect example. The shopping session is the parent record, and the items you add to the shopping cart are your child records with a parent-child relationship between two tables and an ERD diagram that would connect them with a one-to-many, one session for that user, many items put in the shopping cart for that session. So, you know, I was really big into that concept, but I was hating the frameworks. And quite frankly, once Google Docs came along, and Google Spreadsheets in particular, I just stopped doing it. That was web-based CRUD, right? You don't need more than a spreadsheet for most things, and you can slap user interfaces on top of those spreadsheet type things. Google knew that, and they back-ended their whole Google Docs with bigtable. And it really obfuscates everything, because everything is just in reality 2 columns, keys and values. And you can build anything out of a key value based system. Those are kind of like linked lists in Lisp, right? There's nothing that can't be built out of a simple association between 2 objects, because everything is ultimately building up on one-to-one relationships between 2 objects. Okay, so I really ramble. Once you have to choose your framework as your first step, you've chosen something wrong lower down in the pyramid. And you're like, oh, wait, Mike, you use requests to simplify HTTP calls in Python. Yes, I do. But it could use URL lib if I wanted to, the built-in libraries in Python if I wanted to. It's neither beyond my capabilities nor my knowledge. So first, I have a backup plan, standard library. Second, the APIs, the 4 human APIs, thank you, Ritchie, I get your name wrong all the time, but yay you. The 4 humans movement is as big as the Rails movement. An API for humans means it takes the complicated APIs that are provided in the standard library and such things as URL lib, because it has to support edge cases. Changing your request headers, changing your timeouts, doing all this fancy stuff has to be supported in the version of the stuff that's provided to everybody in the standard library that gets distributed with Python. And that is often overkill from an API perspective, because you have to think about a lot of things, and you're often forced into object-oriented notation. You have to think in object-oriented notation for such things as changing your request headers in an HTTP request, and that pushes people like me to pip install requests. You don't even have to pip install requests if you're starting from Jupyter Notebooks from Anaconda. All the popular libraries are pre-installed for you. This leads to people asking, why isn't requests just included in the standard library? Because that's where packages go to die. They get locked down. And the kind of growth that's required in these mega popular third-party libraries stop happening. Requests having to become concurrent, case in point, right? So that gets to the next line of defense. Even though I do pip install requests in HTTPX, the mega popular APIs, the way you interact with these packages, don't change. You see that by pandas using the slice API from the standard library, and things copying pandas using pandas flavor of the slice API for creating rectangular selections out of row and column data frames. So APIs become mega popular and almost get promoted to a non-framework status, a non-third-party package status. It's happened with a request library in Python. It's happened with a pandas library in Python. It's safe turf. While you can think of it as a framework for handling HTTP requests, web requests, and a framework for handling row and column data for the request library and the pandas library respectively, they are less of frameworks than Ruby on Rails or React.js or Java Hibernate, because they don't take so much responsibility. They're less opinionated about what you're trying to do, and just provide back-end API extensions so that you can handle rows and columns and HTTP requests in the first place, right? So stay away from frameworks, but let yourself use mega popular APIs that open up new turf to you, new areas of expertise you can master. And there's always turf that has stabilized and become best practices. And then there's turf that's in flux. And one might say that the web API stuff is in flux. Flask is the most popular one on Python. The way it handles web request routing in particular. The use of decorators for routing requests into certain functions. It's a fairly innovative thing that Flask did, and everyone else is more or less copying it. So you might say Flask is the mega popular one, but in the same way, requests is being replaced, or probably will be replaced gradually, by HTTPX, while people keep the same APIs that they love but move over to the newer packages. That's happening with Flask. And Fastai, I want to say. Fastai is the web framework on Python that is starting to get the mantle of the mega popular APIs, but I would stay away from it because it has not stabilized. I don't want to start putting my 10,000 hours or 10 years in on web development, which I kind of basically don't like in the first place, because I don't like programming genies that have to figure out every variation of the request being made and have to be there all the time. I more like schedulers that I control the input parameters and I control how often stuff gets run and the balance, the load that's being put on the server. I can balance it, and it's a very deterministic way of running your servers, as opposed to web development, which is a big step towards non-determinism, because you don't know who's going to be coming in and making requests of your poof, what do you need, Junie, right? And you have to accommodate for all that, and therefore, handling the load pushes you to the web. Being pushed to the web puts the vendor's hands in your wallet, and it's just a whole downhill road from there. So I pull the servers in-house. I impose a level of determinism on them by doing service and schedule development rather than web development. And everything that I run as a service or a schedule is also a Jupyter Notebook ad hoc thing. So I can dazzle people by doing the deliverables right there in front of them as interactive work sessions. You've never seen people's jaws drop quite so much as doing a complex deliverable that you could easily schedule if you wanted to, but no, you're using the Jupyter Notebook-based version. Which brings me to the next thing I want to talk about. I'm almost 40 minutes into the video, and I'm only getting that next step up the stack from Python. Well, Python alone isn't enough, even though I say Linux, Python, Vim, and Git. Vim will get you the ability to write your Python and to put your Python in those locations on the server such that it becomes a Linux service under systemd and a Linux daemon. Those things you can start and stop with that service command you saw in my last video when I went to see if OpenSSH was running the SSH service. Things like the SSH service are daemons, right? You can create something in Python that's sitting there running like the OpenSSH server, listening on a certain port that you deliberately poked a hole open for, and that's mostly a service. That's mostly a web server, and therefore the funnel of everyone's thought process into an excessively web-centric way of viewing the world. But you might poke that hole open for SSH, to get the type-in interface to computers that are not where you're sitting. So if you wanted access to your home NAS and wanted to be able to SSH and do development work on your home NAS, you would run OpenSSH, change the port it runs on, and poke a hole open in your firewall, and then you could get to that if you knew your dynamic IP that was assigned to your home. So you make a request of your home router. You need to set up a rule on your home router to port forward from your home router's private IP. That's where those non-internet IPs like 198.162 come from. So you put a port forwarding rule on your home router, forward it to your NAS. Your NAS is listening to that protocol on that port, and it hits your home NAS, and that's how you do remote development work with things other than web servers. Because it's a unique challenge. Say a scheduled service stops working and you're not at home and you want to work on it. That's how you get into your home server. There's easier ways than SSHing into your home server, like having something that checks an email address for commands every time and then parses and carries out the commands that are sent to a secret email address, right? It even looks from the sent from, so that other people can't do it unless they're, have the ability to spoof emails and have all that obscure knowledge of how to do that on your home machine. So many interesting things there. But even to have this discussion is the kind of Linux knowledge you should have when I talk about Linux, Python, Vim, and Git. So your Python is going to be the Linux service, the Linux daemon, the thing that you can start and stop with a service command as you would an OpenSSH server. You create those things. One of those types of things you can create is a web server, hence how web development work really does come into the picture. You can start Nginx, GNU Core. There's a lot of stuff that you build into Python as a web server. You can start with one line of code. In fact, it doesn't have as much power as Nginx and things like that, or Apache, but it's there, and you should know how to do it. So you go up the stack. Vim, the text editor, gives you the ability to create text files and plop them anywhere you need so that you can get those services running. That's why the potential end of the discussion is at Linux, Python, Vim, and Git, because Git's the way you deploy your code. You can put your code that you're working on any machine, on any other machine through the use of Git, right? You make one of your services a Git repository. You don't even need GitHub. People think you need GitHub as your centralized repository so that you have to pay Microsoft your $80 a year for private repos. So your dev machine where you write the code pushes up to GitHub, and your deployed machine pulls down from GitHub. It doesn't have to be GitHub. It can be directly from your developer machine if you want to. If you run something like GitLab, it can even be with a web user interface, right? So the shell game is ultimate, but this is still fairly low-level stuff, and the number of options has not exploded yet, right? The number of languages you can choose is less than the number of frameworks you can choose, because by definition, the frameworks are written for a language. The number of languages, or the number of hardware you can choose, is by definition less than the number of languages you can choose, because the languages are written for the hardware. That's why the pyramid is inverted with hardware at the bottom. So the choice propagation explodes as you go up. And when you go up one step past Python, boy, does it explode. You're going to need to get yourself something like the request object, the request package, the Pandas package, and if you're doing web development, something like Fastai or Flux package. You use the mega popular APIs to avoid choice propagation, so long as the itch that you need to scratch is similar to the center line of the average distribution of itches. That center line of the average distribution of itches is where I keep grabbing for. That center line is Linux, for something that'll run on a variety of hardware to provide you code portability. That center line for the language is Python, and frankly JavaScript and C as well, but for me, with my small mind, it's Python. And the center line on the text editor is VS Code and Vim, but Vim in my case, because VS Code is in a long tradition of your text editor screwing you. It is the one most damaging place where the reset button is pressed on you. Think macro systems in your text editor. I can do macros in my head with muscle memory on Vim, and that will never be taken away from me. The macro system that you learn for PFE, the Programmer File Editor, will not change when you switch to Notepad++, which will not change from the macro system you learned for Notepad++ when you change to TextMate, which will not change from the macro system you learn when you change from TextMate to Sublime, which will not change from the macro system you have to learn when you change from Sublime to Atom, which will not change from the macro system you have to learn when you change from Atom to VS Code, and so on down through the line and through the decades. My history starts even before PFE, the Programmer File Editor on x86 platforms. It starts on the Amiga platform, where I guess it was Cygnus Editor, I think it was CE, Cygnus Ed, CED, Cygnus Editor. That was my great macro system on the Amiga with its text editor. So I've gone through a number of agonizing relearning of macro systems. If you like macros, Emacs is really the place to be, because the Macs in Emacs is for macros. But if you don't like carpal tunnel syndrome, Vim is probably a better choice. So Emacs, or not Emacs, but macros in Vim are a sweet spot for me. They've got a Star Wars joke. QNAP. Record, type, Q to stop recording, play back the macro that's @A, do it over and over, @at. So there's a Star Wars joke built into Vim macros, and I can't help but think of it every time I use that bit of my muscle memory, which, by the way, is one of the most useful bits of macro muscle memory you will ever develop in your life. Same with the junior version of that, do something, period. Period plays back your last sequence of keystrokes as an automatically on-call macro in Vim. You just can't imagine what life-changing game changers these are in terms of coding productivity and spontaneous productivity, spontaneous expressiveness, because you want to be as expressive in your text editor as you are in a spoken language. That's what you're really getting at here. And you want as little ability for a vendor or even a free and open source developer, right? You don't want Bram Mullen here changing the Vim API on you the way Microsoft is going to change the VS Code interface on you. Microsoft has very much ability to do that to you. Bram Molyneux, who did Vim, a little bit less so, because Bram was just copying VI, and again, an early 70s technology, 1970s technology from Bill Joy, one of the fathers of Unix. Right? You want to say the internet, it's easy to say one of the fathers of the internet, but really one of the fathers or parent, because, you know, we shouldn't be so gender specific. So Bill Joy was one of the parents of Unix, and he did a lot of interesting bits. He did one of the big rewrites of Unix in order to sanitize and clean it up. But he also did the text editor VI, from which Vim was derived. But he didn't even start from scratch, because he was copying the line editor called EX, which is still built in to this day to Vim. And I'm not so married to Vim. You can use NeoVim. So that gets to the point. Oh, and VS Code even has Vim text binding built in for navigation, but not the Vim macro system, right? So it's not exactly what it's built to be. People go, oh, you don't really need to use VI, Vim, or NeoVim anymore because VS Code has VI bindings built in. Yeah, so try it. Get really used to using Vim or NeoVim, and then go to VS Code and tell me if it really ports over other than basic navigation and copy buffers and stuff like that. Spoiler, it doesn't. So, you know, your text editor is going to let you down and is the biggest enemy of forever improving muscle memory and that sort of telepathic looking control over text files that you want to achieve in the information technology world. Spontaneous expressiveness. And so that gets us to the end of the stack that I always promote: Linux, Python, Vim, and Git, right? You can end the discussion there, but we don't, because we don't walk away from power tools. It's stupid to walk away from power tools. Use them. My last video touched on that point, because the power tool of choice for me is Jupyter. Me likes Jupyter. And even though you can get a read eval print loop, basically interactive Python as if it were a fun toy, a kind of feature-laden scientific calculator that lets you play around with values that are hanging around in memory and change things, and build in documentation, build in embedded markdown. Even though you could get a lot of this through IPython. IPython is a command line version that really is underneath Jupyter. So Jupyter derived from IPython. Very little of this stuff is, you know, an original thought. It's just the next incremental improvement or higher level abstraction, like bringing it to the web, bringing it to a web user interface. So what Jupyter and Continuum.io, now Anaconda, did, well, not them, it's really the Jupyter organization, but Anaconda made it an easy install, was to bring to the masses a easy way to play around with Python. It's Python for humans, because it comes up through the web browser, and it feels exactly like you're running Python in the web browser, although there's nothing like what you're doing. There's a clever bunch of stuff going on in the web browser so that you can run Python in, you know, formal, familiar Linux kernels. CPython, the standard specification Python from Python organization, the Python Foundation, and Guido van Rossum, is what Jupyter runs. It just does it through a clever stack. You know, things sit on things until you're running real Python in a web browser. So it's not merely running Python in a web browser, it's running it with a REPL environment with built-in documentation and stuff. So it's addictive, it's fun, and it's modern literacy. It's reading, writing, arithmetic, and Python, right? It couldn't be that way if you had to figure out how to run your Python code. Where to run your Python code's another matter, because there is a chasm here, because getting Python code to run in a Jupyter notebook, no problem. The hello world is dirt simple. Having that hello world run every hour according to a schedule in a way that can't be stopped is beyond the realm of most people who use Jupyter notebooks. They just can't do it. They would never know how to do it. And so that's a big part of what I bring to the picture, because moving from Jupyter notebooks to headless Linux servers in the cloud or otherwise, and more often as LXD containers on a home NAS, is worth doing. There are unlimited reasons to want and need to do that. It's extremely general and generic and broad. You remember at the beginning of this discussion, I talked about putting your life into becoming, a surgeon, or some sort of data scientist, even scientist. Your knowledge becomes very specialized and keyed. Your choice of employers restricts your choice of career changing, pivoting, changing to similar but different careers that feeds your soul in different ways, narrows and constricts. I want to become a different kind of specialized surgeon. Well, no, you're hitting the reset button in a big way, because all that muscle memory is tied to whatever organ you learn to specialize in. So all this infotech stuff I'm telling you about is on the opposite end of the spectrum from that. It's the tech that every company, every startup, every size of company and startup, every private venture, every hedge fund, every student more and more often has to do. It's modern literacy, it's modern infotech literacy. And learning to do it, learning the Linux, Python, Vim, and Git stack will serve you for the rest of your life in almost any context you're in, because you will know more and you will know it deeper than all these vendor-dependent people who are drinking at the teats of whatever platform and framework du jour they are. Now, the saving grace of that is power tools are generally easier to learn and be productive fast with, and that gets us back to the fact that even in the Linux, Python, Vim, and Git world, you want yourself those power tools. You want to be able to pick them up and use them yourself, which I'm currently doing in order to run my Linux containers on my home network application server, on my home NAS. That way I don't pollute the proprietary software. Even though it's Linux, it's still proprietary software. It's provided by QNAP. I don't want my Linux services, I don't want my scheduled Linux services to be running in my QNAP NAS, sorry for the alphabet soup, but in my home server's top level proprietary memory, even though it's Linux. I could do it, I know how to do it, I don't want to do it. You want to contain everything that you put onto the system in something that you could move that container and have it running the same way on any other parent type system that supports Linux containers, you see. So, choosing exactly the right levels to step in to make the complex simpler. I don't say simple because not all these APIs are simple. There's certainly a lot about Linux that's not simple, and there's even more about the Vim text editor that's not simple. It's steep learning curves on some of this stuff, but it will serve you for the rest of your life. It's the opposite of these power tools like VS Code and the Google Cloud Platform that lets you get really productive and do really powerful things quick, except you're going to have to relearn 90% of it in the next 5 years, and not with a casual drift of like moving from Python 2.6 to 3.10 over a period of 10 years to do one numeric version increment in Python with most of the core APIs and the standard library stuff staying exactly the same, with only innovations like F-strings and concurrency being layered in as optional new APIs to use. It doesn't obsolete any of the old stuff you knew, except for having to use parentheses now with your print statement. That's about the biggest thing. Okay, I'm getting close to my destination, so I've got to really hit this thing home going up the stack. So I tell you, in addition to just Vim as your text editor, you choose other text editors. Instead of just Python as your programming language, you choose other programming language environments like Jupyter. And the next thing, which is causing me quite a bit of pain, because if you go an abstract level higher than that, you can imagine the choice propagation and the obscurity of it. It's not merely choice propagation, but it's a specialized itch, right? Jupyter, to run Python, is so popular among data scientists and financial people because everyone has that itch to scratch. Everyone needs to run Jupyter. Everyone needs to run Python code easily without being a technology person, without being a infotech person per se. They tend to write sloppier code, more memory leaks, but it doesn't matter because of the context and the one-off nature of what they're doing. And, I don't write one-offs. I write things that should be able to be promoted to libraries that you can pip install, that the public can use, that have been hardened and time-tested and all that. So to go from Jupyter notebooks, Python code in a web browser, to things that you could pip install so that anyone using Python can do, there's only one real choice right now. And NBDev is scratching an itch that I have that very few other people have. However, the muscle memory is really new to me, and I'm having a difficult time with it. It seems like it's actually done quite well. I am not unhappy with it. I don't know how it could be done much better or much easier. However, frameworks. NBDev is a framework for turning Jupyter notebooks into pip installable packages, so that developers, that serious formal developers like me, who could just as well be in Vim or VS Code, can instead be in a Jupyter notebook with the advantages of the REPL environment. Now you might say, but VS Code gives you the REPL environment without it being a notebook. Again, tried it, hate it. There is a difference between the Jupyter REPL environment and the VS Code REPL environment, even though Microsoft is trying to make you think there's not. In fact, Microsoft is using the IPython notebook and Jupyter engines to do that trick inside of VS Code. And that's fair enough, but you can't embed the markdown, and you can't, make it look like a pretty web page for sharing. When you push it to GitHub, it doesn't come up looking like an easily shareable thing. It just isn't the same spiritual experience as a notebook. And the whole concept of notebooks came from out of academia, where there were other packages, proprietary packages. I think, Maple and Matplotlib. I get Matplotlib and Matlib, but there's a few of them out there that had expensive licenses for students, which was untenable. So of course the free and open source world stepped in, and that evolved into Jupyter Notebooks. So to get reproducible code that can be handed around, derived from out of academia, but became the notebook concept, which is beautiful, which is addictive, which is different than just .py files under VS Code for reasons that are hard to explain other than do it for a few years and see what I'm talking about. So I want to stick to notebooks for ad hoc projects, for early stage development work, but I want them to also be formalized pip installable packages, and that's NBDev. And there's so much I'd like to say there, but that would be a separate video. To suffice to say that the framework issues that must be dealt with, the highly opinionated stuff, the magic incantations, are turning out to be a little bit difficult for me. Perhaps I'm just not doing it enough. I did my first package OAuth, O-H-A-W-F, because OAuth authentication is awful, and I wanted to be able to do it with just one line of code, 2 lines of code, one to do with the import, one to invoke the creation of a credentials object, a Google credentials object. Under many contexts, of course, there's ways to do this in the sort of developer way, where you wouldn't have to use a package like mine, but then you're creating a whole bunch of other dependencies, a service account, so you can't switch to doing it from account A to account B, or user A to a user, Google user A to Google user B, different people's data, without creating a service account for that user, needing their elevated, you can't hand them the ability to use these tools themselves unless it's being funneled through you. So with OAuth authentication and a pip installable package, you can funnel it basically through Google, who you're authenticating against. There's no way of getting around that. But then a pip installable package, which is a great infrastructure framework, you're not reliant on some particular server, some particular developer, some particular service to provide you your authentication, and you can do that against any Google account you have the username and password for. Okay, so I created OAuth using NBDev, and I'm now in the mode of aggressively expanding it, adding features, supporting different scopes, different Google services you can do it against, using different names for the credentials, the pickled credentials, so that you can switch with a name between different stored pickled credentials, so you can rapidly change what user you are without restarting services or scripts or whatever. And I find it a challenge. I broke OAuth and got into that desperate kind of mode where you just lose control of what's going on. And then I had to leave on this drive. That's why this is all very much on my mind. So I'm getting back to it. I'm gonna conquer this. And it's like lit up light in my head. I feel the next thing I wanna code. It's reached that love-worthy point. But I gotta master one more framework. Just when I'm like, I gotta learn Jekyll now to do, I need to learn the template system under Jekyll in order to do web development under GitHub's GitHub.io system. So just when I'm like, okay, one more framework, now I gotta finish polishing up my muscle memory on NBDev, because this is a skill that I really want. I'll start to do more of the talking head Python work sessions and show you some samples of how you can knock people's socks off. Here's an ad hoc project. Here's an ad hoc project from scratch. Not borrowing, not copy and pasting, just doing a few package imports and then having APIs that are so simple that you can start writing your app from scratch, including database stuff, including SQLite database stuff, because the API of SQL is so profoundly simplified under SQLite Dict, a pip installable package that makes the SQL the incredibly optimized, written in C, included with a Python standard library and a lot of other things. It's one of these embedded things like the regular expression engine. The SQL Server database is embedded into a lot of things, including Python. So it's easy to get, but it doesn't mean you know yourself some SQL. Yet another kooky, different API. A lot of people know it because it reads a lot like English, and your first, select asterisk from table name is an easy command to kick off. But you get all these problems that come with SQL. I don't want to extend the video. However, when you slap on simple APIs on top of SQL, namely the key value API, the Python dictionary API, the JSON, JavaScript object notation API, key value pairs. Key value pairs are the web itself. You plug in a key, you get out a web page. Web address is a key for a web page, which is the value, key value pairs. And that list of keys can grow longer and longer and longer to millions or billions of individual potential keys you can plug in. How do you still have performance? Because of years of optimization of that problem. Nested hash tables, so that the speed of lookup, even against millions of values, is deterministic in nature, because no cluster that it has to scan is bigger than a certain size. So anyway, key value pair APIs are one of the true APIs to rule them all. And Python has it built in the form of dictionary objects. So the dictionary object API can be used to store data in SQL, to store data in SQLite in particular, using the pip install SQLite dict package. So it has been elevated up to the level of requests in HTTPX in my mind, elevated up to the level of pandas in my mind, now SQLite dict, because you need the optimized performance of SQLite in the background, handling your key value pair stuff in the foreground in the Jupyter Notebook. The context manager is important. Lots of little sub-discussions here. File handles are important. Things escaping the context of the context manager is important. There's lots of little subtleties here. And that is where I'm putting most of my muscle memory into right now. Even though it's pip install libraries, it's third-party stuff in a number of cases. Pandas, requests, and SQLite dict, they have universal timeless APIs, so it's okay. And almost every project in the field of analysis, analyzing data, business analysis, quant stuff, is handled by these few tools, right? Because you can apply your data science libraries under scikit-learn under the data that you went and collected through a web crawl using the requests package and SQLite dict to store the response objects. So like everything can be written just kind of sitting there. You can go, here, let's write a web crawler, and you could sit and in one session show someone how to write a web crawler. And they'll be like, that's all there is to it? They'll be like, yeah, well, there's a lot more under the scene, because you see this package that I pip installed does this other package that I pip installed does that. And this is not pip installing Scrapey, I will tell you. So if you want a powerful Python-based scraper with its own kooky API, pip install Scrapey. For some people, in some cases, it's worth it, but no thank you. Beautiful Soup, on the other hand, with your raw response object from your requests package is up my alley. There's nothing mysterious. It's easy to explain. It's easy to do. It's fairly fast and optimized on the crawl, on the subsequent retrieval of your crawled and stored data. Everything's fast, everything's simple, everything's beautiful to look at. There's very little weirdness and gotchas. There's a little bit of weirdness and gotchas as I move more and more towards concurrency, replacing requests with HTTPX. But it has profound optimization impact on site crawl. So, give me some of that concurrency. Okay, so I've been at this for how long? Well, I moved to New York in 2006. I was already billing myself as an SEO from probably around, let's say, 2000. Before that, I was like a print product production manager, but it was clear the web was the place to be, so I ditched my, oh my God, what do they even call it? Well, it's PageMaker, Quark Express. I ditched my Quark Express and I picked up Apache, right? So I've been doing web and SEO stuff since about 2000. You might go back to 1998, really, when I was with a company called Profit 21 in Pennsylvania near Philadelphia, which has subsequently been bought up by companies being gobbled up. I think Epicor is now the top company in the gobblers. It's one of the, business software things like PeopleSoft. Oh no, not PeopleSoft. That's been gobbled up. Like Bond. Oh, sorry, that's been gobbled up. Like SAP. Okay, SAP still exists. Well, I worked for one of those, a junior version of one of those, and started doing web stuff there in probably 98, 99. So SEO and webmastering, been at it for a while. Let's call it, 20 years and some change. And so I know what the pain points are. I know what drift. I know what, fire in motion are. I know what all these pain points are for, even seasoned developers who can take up power tools over and over and play the fire and motion game and be successful in that game. That is not me. I am more a small set of tools and getting better and better at them for life. Hence my big draw and appeal to the Unix API, right? The Unix API is the thing that really pushed this on the world and popularized it. It's what popularized the take-up of Unix, which popularized the take-up of Linux, which popularized the take-up of the LAMP stack, which popularized the take-up of the web, which popularized the take-up of where we are today, right? So, as you peel away the stacks and you find what's love-worthy, for me, I got down to Linux commands, Unix commands, the Unix API under Linux. And I'm like, that's the love-worthy bit. I want to know how to do that because it'll never go obsolete on me. And I feel pretty good doing it. I don't hate it in the way I hate Adobe Illustrator. And the whole kit and caboodle that comes with staying polished on Adobe Illustrator over the years, having to pay the Adobe Graphic Arts Guild $500 a year for the whole creative suite, when you're only like loading these packages 1 or 2 times a year for a side project. Inkscape and GIMP and Inkscape and Blender, and for structured graphics, for motion structured graphics, the replacement for Flash I'm still working on. But anyway, so many side discussions there. You don't have to. I got to take up my tools carefully because I plan on living with them for a very long time. You still take up your power tools, you still dabble in that world that everyone else gets infatuated with and hangs their hat on, bases their career on. But meanwhile, you have a muscle memory driven secret weapon at which you are always getting better at, which you are always improving your macros and, improving your keyboard shortcut mastery and, becoming more telepathically in control of text, becoming more familiar with areas of systems that run your code and resources that are in common across all systems where you might run your code and need those resources. So it's secret weapon stuff. And during these work sessions where you seem to be doing this incredibly high level stuff of a modern developer relying on their framework crutches, and then you step into this other world here and there momentarily to do things that are easier in the old school world. I should probably show you my shirt here. It's worth taking it out of. Old school is cool. Old school. Old school. Doesn't say it's cool, but there you got the idea. Because I'm going to stop this video real soon. I'm on a bridge at kind of a standstill. And it's a good time to wrap these things up. What point do I want to hit home? Well, I told you about Linux, Python, and Git. I told you about the inverted pyramid with the hardware, the operating system, the programming language, and then kooky framework and third-party package installs on top of your language. And then, of course, on top of that, your applications, the things you write. So it's not until you get up to that top slice that, you get to the top of the pyramid. And arguably, even then, you're not at the real top of the pyramid because, you write something. What about the deployment story? What about different hardwares out there? So it's like your inverted pyramid and then a whole bunch of other little inverted pyramids out there with you dropping your code in the top of those inverted pyramids. So you need to know more DevOps, more deployment, blah, 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 maybe more hardware. The wheels system under Python is important. You used to have to use Anaconda. One of the big changes in data science, although they don't know it's coming, is Anaconda going out of the picture. In fact, data science and Python in the web browser and Anaconda are all tied together in this kind of inextricable mix, because I challenge anyone to get Jupyter Notebook running without the Anaconda install. And then I challenge anyone to say that that doesn't exist because of the data science community, because of novice tech people having to do more ambitious data work, right? Scientists, financial people, they need the Jupyter Notebook environment. I want the Jupyter Notebook environment. They need the Jupyter Notebook environment. So hence Anaconda, hence their changing of their licensing agreement now, so that you have to pay if you use Anaconda for commercial use. But Python Foundation hasn't been standing still, and pip installs are much more robust than they used to be. It used to be that you couldn't just pip install pandas because NumPy was a dependency of pandas, and NumPy had to be compiled with the tool chain. So you had to apt-get install or some other form of install all the components required to build with the C toolchain NumPy, and then NumPy would be compiled for your hardware, and then you'd have a binary that was very tied and very optimized for your piece of hardware. The new trend is distributing the pre-compiled binaries for the sufficiently abstract hardware. You're not going to squeeze all the performance out of your hardware on anything that you pip install or on anything else in technology these days. That's why game platforms seem to be so much high performance in a lot of cases than generic computers, because they know all about their private APIs and don't have to limit themselves to lowest common denominator hardware, where a lot of these, hardware thunking layers, so that any x86 is all x86, right? You're walking away from a lot of hardware capabilities when you do that. But it's worth doing because you don't have to learn as much, your code is more portable, and if you're going to be a game developer, you're in a different world anyway, and you don't need to be worried about the portability so much. You're going to make your millions and move on to your next game on the next console, right? Different worlds. It's kind of the same with mobile app development. You don't need to know so much. You just fire and forget. That's why, mobile apps being portable between different platforms like iPhone and Android to this day continues to be hard and a challenge, and makes the apps look and feel and behave less awesome than natively written ones, right? These are those issues. Okay, wrap it up quick. NBDev. I'm going to be delving into the nuances of NBDev, probably polishing up the first package and also most important package, OAuth, to handle OAuth 2 authentication against Google services. I mean, it's working. I just want more stuff like loading a list of scopes externally, which I already did. That was today's work. That's actually out there and deployed. But don't pip install OAuth at this moment. Give me another day or so, because I've got to get it working again, because I broke it because I don't know NVDev that well. I want to support more granular keeping of separate pre-canned credentials, so that you can switch between those credentials rapidly without having to re-log in every time. And that's about it. So I just think there's not much in OAuth, or OAuth, OHAWF, because OAuth is so awful that I decided to create a pip installable package to make it like 2 lines of code for me. And that'll be done soon. That'll be done in the next couple days. My motivation is real high. But over the past 20 years, I've kept implementing and re-implementing and re-implementing SEO software, full suite of SEO software, from keyword position tracking to long tail writing suggestion engines to everything that you can do with your Google Search Console and Google Analytics data, and integrating with other third-party apps like SEMrush and Ahrefs. I use all their APIs. I'm familiar with it. I made my own proprietary suite of products using it. It was for hire for previous employers. Not until Pipulate was it for myself, thanks to the generosity of one of my employers at Flying Point Digital, now part of Women's Marketing, now part of Stella Rising, where a dear friend of mine, John Morabito, works. And you know, Pipulate was for hardcore developers still, even though I simplified all of the hardest tasks, like connecting to Google Analytics and Google Search Console, pushing data in and out of Google Sheets. Even though I made the API simplifications I needed for that, who else out there is going to build that in the world of SEO? No one, right? But I did. I loved it, and I built endless things out of it, although those things I built out of it were kept private. Those are in MLSEO, which is a private version of Pipulate in a private repo in GitHub that I use just for myself, which has a bunch of other stuff like the, anything using natural language processing, the more advanced crawl features, anything that creates deliverables that are just for my employer that I wouldn't share with the world, because, I created these deliverables under the instruction, under the ideation of my boss, who's brilliant at figuring out the deliverables that people in our organization would want and need. There's no sharing that stuff. So even though it might use the things in Pipulate, I tend to not. I tend to use MLSEO because I even changed the Pipulate core code for new parameters, new capabilities. So things get out of sync with each other. So right now I have 3 libraries that I'm managing, and between the 3 of them I can do pretty much everything. It's OAuth for authentication against Google services, and it's Pipulate for the public-facing SEO tools, and it's MLSEO for the proprietary private SEO tools. Now there's a certain amount that always can be moved from MLSEO back out into Pipulate. And then techniques improve over the years as the Python package improves. F-strings come to mind. Code can be made just much cleaner with F-strings. I've learned quite a bit more about object-oriented code that doesn't make me vomit, thanks to the OAuth package. The OAuth package, where I cut my teeth on OO style programming, object-oriented style programming, that I actually can understand, that I actually can wrap my mind around and get benefits from, as opposed to having implemented it in a more procedural way of programming. Let's see, in imperative, imperative is something different. That's like SQL and HTML. But procedural, let's call it procedural, where, it's just normal functions. They're not classes. Okay, a whole nother talk on that. But I get better at things. The Python platform gets better. Concurrency comes onto the picture. Things I used to do, I don't need to do anymore. Things go away completely. New things come into style. Social media things come and go. So there's always a need to sort of rebase, to sort of pull things together in a new or different way. And that's what I'm doing right now. And that's what I'm going to be doing with you, hopefully on the free and open sourceable bits that I can move back into Pipulate. So there's a rebasing of Pipulate coming up where I'll keep the old API, so anyone using it, it doesn't really break on them, but I'll be adding a fair amount of new stuff. Concurrent crawler is the top things that comes to mind there, and I may even move it under NBDev. It might be time for Pipulate to be managed under NBDev, so I can continue to use Pipulate in work session style in the notebook, and then move it over server based for all those things that use it on a scheduled basis. So anyway, that's a good place to end it. Thanks for joining me. Thanks for hanging with me for this hour and a half. If anyone listened through the whole hour and a half, let me know. Post a comment saying, hey Mike, you were interesting the whole time on that drive. I'll be like, thank you very much. And hope to see you again soon, and don't forget to subscribe.